I like this problem. It's got some variation with more than one variable, but if we take it step by step, it's actually pretty easy to solve. So sales is varying directly as advertising and inversely as price. Okay, that should make sense. You spend more on advertising, your sales should go up. They're directly related. But if you increase your price, your sales usually go down. So they're inversely related. How can I come up with an equation? Well, as soon as I see the vary, I know that's where my equals goes. So S equals, and I'm only going to need, even though I have more than one variable, only one constant, so 1K. I'm going to have Ka, so they're directly across from one another, and then inversely, so the P has to go in the bottom. All right, now let's figure out what K is by using the information. It says sales are 10,000 when we spend 500 on advertising and sell our items for $2 each. So 10,000 equals K times the 500 over 2, multiply through by 2, and then divide by our 500, and we find that K is 40. So we plug that in, and this is our nice equation. S equals 40A over P. Now, what happens to the sales price? Sales, if price is increased to $3 an item and advertising is increased to 800. Maybe you had some additional costs by your suppliers and you have to increase your price. You convince the boss, hey, we spent a little more on advertising, it's going to offset it. Well, are you going to be right or not? Is the boss going to be happy? Let's find out. You're going to put your 800 in for your A, your 3 in for your P. So we would 40 times 800 divided by 3, you get $10,666.67. Well, we've increased our sales, yes, but have we increased it enough to offset our increase in advertising? Sure enough, we've only increased our advertising $300, but our sales have increased over $600. So I think the boss would be happy. One last example with more than one variable. This doesn't really have a context, it's just some algebra. We want to suppose that y varies jointly as x and the square root of z. So jointly means it's direct variation with these two things. And then inversely as the cube of t. Okay, we've got to read these really carefully. So y equals one constant variation k, and it's directly with the x. It says and the square root of our z. And then inversely, so that's going to go in the denominator, the cube of t. Now that's not cube root, it says the cube, so that means t to the third power. Finding k is the second step. So plug in what we know here, the y, the x, the z, and the t, and let's work it out. So square root of 4 is 2, 2 times 2 is 2, 1 cubed of course is 1, divide through, and k is equal to 4. So we're going to take our 4 and plug it into that original variable equation. Then we're going to solve. It says, what happens when x is 1, z is 9, and t is 2? Okay, so this last part. If x is 1, z is 9, and t is 2, well, I plug in my x, my z, and my t. The square root of 9 is going to be a 3. 3 times 4 is going to be 12. Okay, so that's on top. And then 2 cubed is going to be 8. And 12 over 8 would simplify to 3/2.